Okay, so now let's look at our third problem. So we want to write a recursive function to find the number of times a specified value appears in an array of integer. So we could do that. We could find an iterative solution, a very concise and clear iterative solution using a loop. So we could just loop through this array of integers, and then if we find that specified value, the target inside of this array, whenever we visit an element, we just increment the count by 1. And after this for loop or a while loop, we just return the value of this count. So we are done for the iterative solution. As we said, we want to develop our recursive thinking skills. So we want to look at how we can come up with a recursive solution in this video. So now, just as our previous examples, we want to get the definition of our recursive function so that whenever we come up with our recurrence relation, it's straightforward for us to decompose our original problems into subtasks. So the same thing, we have a definition for our first problem, how we can come up with the smallest element in an array using recursion. So now we just want to have a definition. Okay, so the definition of this recursive function would be we want to get the number of times target value, or a target value appears in an array of size or length n. Okay, so how we can translate this into Java programming language. So we could say this is a public static, and our return type should be integer because the number of times. So we want to return an integer. So let's say the name of this recursive function is numOfOccurrences. Okay, and we know the target value appears in an array. So that's to say we have to pass in an array as a parameter. So we have this array pass in, and this array of length n. So we want to have an n as a parameter because each time we will decrement n by 1 so that we can look at identical smaller subproblems, and then we can solve the subproblems, and eventually we just go down to our base case and we can return the control back to our caller. So we can just get the result of my numOfOccurrences recursive function. Okay, so that's all the two parameters we need. We also need a target value so that we can compare each of those elements inside of this array with this target value and see whether the element is equal to that target. Okay, so we just have the definition for this recursive function, and we have already had this signature for this recursive function. Now, just want to come up with our base case in the recurrence relation. Always, just like always, we want to get the base case, and we want to establish our recurrence relation. Okay, so what's the base case of this problem? So think about if we have an empty array, okay, what the target, whether there will be this target value inside of this array, how many times this target value appears in that empty array. 0 times, right? So it should be very straightforward. This is the simplest instance of the problem. So if we don't have anything inside of this array, then we won't be able to find this target, and the count of this target value should be 0. So how we can represent this is an empty array, we could use this n to represent it. So if n is equal to 0, then we say 0 because we didn't find it. We couldn't find anything in an empty array. So the count of that target value should be 0. Okay, so what about the recurrence relation? How we can establish it? Okay, so now let's look at this the different example here. So we should have different example because we assume that we have some duplicates inside of this array, and we would like to see how many times that duplicates appear inside of this array. Okay, so that duplicates should be the target you want to look for, right? So let's say I have 4, 3, 12, 4, 3, sorry, 3, 2, 1, 3. Okay, so this is our input. This is an array of integers. And our output and the target is equal to 3. And what should be the output? We want to see how many times 3 appears inside of this array. So we have 1, 2, 3, 4. Okay, so it will appear 4 times. So this is our original problem. How can we decompose this problem into the subproblem or the subtasks? Okay, so just like what we have down for the first 2 problems, maybe we could try, we just look at the first several elements, exclude the last element, and look at the first several elements here. And we want to see how many times 3 appears inside of this subarray, okay, of length n minus 1. Okay, that seems like a good approach. So we want to first look at the first subtask is we want to see how many times number of occurrences, how many times these target, which is 3, appears in an array of length n minus 1. So we want to just look at minus 1 elements instead of n elements. We want to look at the first minus 1 element inside of our original problem. And we want to know how many times this target has been appeared inside of it. So I know after calling this numOfOccurrences recursive function on this array of length n minus 1 to find this target, the number of times it appears, it will give me back 3. Okay, so that's my first subtask. We decompose this original problem into 2 subtasks, and this is the first one. I get 3 appears 3 times in the array of n minus 1 elements. Okay, the first several elements exclude the last elements here. Okay, so this is the first subtask. Now we want to look at the second subtask. So we have already finished looking at the first 7 elements. Now we want to look at, so this original problem, we have 8 elements. We have already seen the first 7. We have already handled the first 7 elements. Now we want to move on to the last element. We want to see whether this last element is equal to our target. Okay, if it's equal to our target, then what we want to do. Okay, so if it's equal to our target, then I know this 3 is equal to 3, then I know the 3 appears 1 times. Now I just need to get the result of A plus result of B. That's to say 3 plus 1. Okay, if they are equal, if the last element is equal to 3. Otherwise, what we want to do, so if array n minus 1 is not equal to the target, let's say if the last element is no longer 3, it's like 12. So our original problem output should be 3 instead of 4. So now what we should do. So I know the output of this case should be equal to 0 because when we look at the last element, it's not 3. So we don't count it. So we just need to combine the 3 plus, like add up this 3 and 0 and get 0. here, 3 plus 0. It depends on whether the last element is equal to 3 or not, the target. Okay, so that's the general idea. So I just want to go back to our original array. Okay, so how we can convert this recurrence relation into Java code? So let's look at it together. So what we want to do here is, we know we have a condition here for the task B. Okay, so that's where we want to start. So we want to have this array n-1. If it's equal to target, then what we want to do. So if it's equal to 3, we know this 3 appears once for this last element here. Okay, so we want to return 1 time. Okay, this 3 appears 1 time for this array n-1, plus the number of times it occurs in the array of length n-1. So that's how we can come up with the solution. Else if array n-1 is not equal to target, that's to say the last element we look at is not equal to 3, then it doesn't count. So we don't have that 1 plus. We don't have that because it doesn't count because it's not 3. We just need to return what a subtask give back to us, right? We just need to return numOfOccurrences. We want to see how many times this target appears in the subarray of n-1 elements. Ignore the last element when the last element is not equal to the target value. Okay, so that's how we can come up with our solution. So we have the base case, we have the recurrence relation. I will leave it to you to try to think about how you can come up with a recursive, tail recursive function here. Okay, so if we just want to test it out, you can say numOfOccurrences of array to length. Let's say we want to find 3 in it. Okay. So now if we compile it, we could see that it should appears no time because I didn't change this array to our test case here. So I will copy it. And it's correct because 3 doesn't appear in this array. So let's have a different array. So let's say array 1 here, and we just change all of them to array 1 here. Okay, so let's just rerun it. Okay, so our array, the 3 appears 3 times, 1, 2, 3, because we changed the last element to be 12. If we change it to be 3, then there should be 3. There should be 4 3s. So we should see the 4 as a result. Okay, so that's the general idea of how we can come up with our own recursive solution, and I will leave it to you to try to convert this pure recursive function into the tail recursive function.